what I want to show you is how to factor out a GCF. This will help you also finish off the rest of your problems on your worksheet. So, when I'm factoring out the GCF, what the GCF means is the greatest common factor. That means the number or term that goes into every, that goes into every single term. So when I look at here, and I look and I say, all right, well, all my numbers right here are all even. So obviously when they're all even, I know that 2 is going to go into all the numbers. But it says the greatest common, so therefore I want to find the largest number that goes into all of them. And I look, and so therefore I look for, you want to look for the smallest number, because obviously you can't go any larger than what the smallest common number is. And I look at, and I say, oh, well 4 is obviously my smaller number out of 8, 28, and 4. So therefore 4 is going to be the largest number that all 3 of these numbers share as a factor. So, and I notice that works. So I factor out of 4. And when I factor out of 4, what I'm actually doing is I'm doing the reverse distributive property. You remember when you do distributive property, you're multiplying your outside term times your inside term to go ahead and expand it. Well, now what we're doing is we're taking it back out. So we're going to think of it as division as you take it out. So 8 divided by 4 is now going to leave me with a 2. 28, negative 28 divided by 4 is going to leave me with a negative 7. And 4 divided by 4 is going to leave me with a 1. Now, the next thing we need to look at is now our variables. And our variables is a little bit different because now they have exponents. And what we need to do is, again, we're still looking at division, but we're going to have to use the laws of exponents to go and figure out what our new exponent is going to be. So I look at my a first, and I notice, all right, what is my greatest common factor between my a's? And you notice that, well, you have to look at what exponent is the lowest exponent. That's going to be the greatest that they all share. So the largest exponent I have is a squared. So what I'm going to do is, as I pull out an a squared, what I'm doing now is I need to go ahead and divide, because when you multiply an exponent times a variable with an exponent times another variable with an exponent, as they're the same variable, you add the exponents. So now when I take them out, I'm going to have to divide the exponents. So let's go and do a to the 4th. Remember, divided by a squared, that equals a to the 4th minus 2. So if I take out an a squared from a to the 4th, if I take out my a squared, I'm left with a to the 4 minus 2, which is going to be a squared. If I take a cubed divided by a squared, I'm left with a to the 3 minus 2, which is a to the first power, which is a. And then if I take out an a squared from a squared, I'm left with another 1.
Aren't you subtracting? Why are you doing the division then?
Because when
you're making it a lot more confusing.
When you're doing distributive property, you multiply across, correct? 2x plus 2. Now, if I want to factor it out, you're dividing it out. There's no adding or subtracting. So you're dividing it out. So it becomes 2x plus 1. The only thing I'll say in multiply and subtract is that's with your laws of exponents. When you divide exponents, because that's the process we're doing, is dividing and multiplying. When you divide exponents, or divide the same term with exponents, you subtract the exponent. That's what you're doing.
So can't we just subtract them instead of having to divide?
No, dividing exponents is dividing the terms with exponents. You have to subtract the exponents. You're not subtracting, the process is not subtracting at all. Think about it this way.
I understand what you're saying, but the way you're writing it out is confusing.
Think about it this way. Well,
because 4 over 2 to me is 2.
okay, think about it this way. Guys, I need you to be quiet. If I was looking at this, if I a to the 4th is this, right? A times A times A times A. Correct? Divided by a squared. Right? We know that a over a equals 1. Correct? So that equals 1, that equals 1. So I'm left with a squared. So therefore, if I rewrote this in the exact same format, if I did a to the 4th, divided by a squared, that essentially means a to the 4 minus 2, which is equal to a squared. That's how you get to a squared, okay? So, now with all this extra I added side stuff, now to go ahead and look at my b's, I look at my common b factor and I notice that b squared is going to be my most common term. So therefore I need to take out now a b squared. Oh shoot, I messed up. I didn't need to erase that. That's going to be 4a squared, right? And now my common term is going to be b squared. So, when looking at this, I go ahead and say, alright, well if I take out a b squared up here, 4 minus 2 is going to become b squared. B cubed minus b squared is going to be b to the first power. And again, b squared, if I take out a b squared from b squared, I'm left with 1 again. So that's actually a plus 1. So therefore my final answer, as I factor out a 4a squared b squared, I'm going to be left with this inside term. And if I wanted to go ahead and check my answer, I could just go ahead and do the distributive property back again. And just multiply it back through. And remember now when you multiply exponents, you're actually adding, when you multiply terms with the same exponents, you're adding them. So this becomes 8, a to the 4th, because a squared times a squared is going to be a to the 4th, and b to the 4th, minus 28, a cubed, b cubed, plus 4a squared, b squared. And I go and look at, and I got the exact same answer back, so therefore that's how you factor out the GCF.